Okay, I think we're good to go for now. So welcome everyone. This is Yana from Endeavor. I will be your host today. I want to thank you all for joining our Rethink webinar, both all of you here on Zoom and the ones watching from our LinkedIn live stream. We're really excited that we're relaunching our Rethink series, and their goal is to curate tech discussions about the biggest innovations and disruptions happening right now. And its panelists are always people who are world-class experts and are transforming the industry globally. So let's move on. Tonight we're hosting 4 really exciting figures, and the main topic of the discussion will be touching the limits of machine learning. So we have our moderator, Mr. Konstantin Arkoudas, who is the Senior Manager of Applied Science at Amazon's Alexa AI. He leads efforts to apply deep learning to natural language understanding, and prior to that, he was a team leader at Bloomberg AI. Also, we have Mr. Serafim Badzoglu, who is the Chief of Computation at SEER and co-founder of DNA Nexus. His work is focused on computational genomics and the application of AI in biosciences, and he has served in several advisory boards. Next up, we have Mr. Konstantinos Daskalakis, who is a professor at MIT. He has resolved long-standing open problems about the complexity of mass equilibrium, and he has been honored with multiple awards. And last but not least, we have our Endeavor entrepreneur, Mr. Maris Stavropoulos, who is partner general manager at Microsoft and co-founder of Softomotive. Softomotive is one of the leading providers of robotic process automation globally and was acquired by Microsoft. And I think that's it. Without further ado, I'm inviting our moderator, Mr. Arkoudas, to take the lead. And for all of you who are watching on Zoom, feel free to post your questions in the Q&A section below so that the panelists can answer them in the last 30 minutes. Mr.
All right. Yes. Thanks for the introduction, Ivana. It's a pleasure to be here. So today we're going to be talking about machine learning and AI in general, about the good, the bad, and the ugly in a wide-ranging discussion. So let's get started. The last decade, without question, has been a so-called AI spring that has been enabled by rapid advances in machine learning, especially in deep learning, which have already had a tremendous impact on economic activity on society at large. Now, later in the discussion, we're going to talk about the limitations of machine learning. But for now, let's start with the remarkable accomplishments of the field in recent years. So this is going to be a 3-part question. Number 1, what do you think machine learning does best? Number 2, what do you think has been the killer app, so to speak, of machine learning so far? Or perhaps let's say the top 3 most impactful applications of machine learning. And finally, number 3, where do you think machine learning is best poised to make an impact over the next decade? Konstantin, we'll start with you.
Okay, so hi afternoon, everybody. Good afternoon, everybody. Machine learning is very good at pattern recognition, and not so good, as I hope we'll discuss later, in understanding causal relationships between the phenomena that it's studying. Some remarkable recent successes of machine learning have been solving very hard games like Go and poker, playing at a human or beyond human level. Of course, as impactful as this may be from a scientific standpoint, it hasn't found applications in practice. I think one of the major impacts of machine learning, believe it or not, has been in understanding how to sell things to people. And relatedly, how to present them with engaging content so that they stay engaged and see more ads and buy more things. So it's not the most let's say interesting from a changing the world perspective, but it is one of the biggest applications of machine learning. And of course, it has been transformative in the internet economy. Yeah, so what was the third part of your question? I'm sorry, I missed that.
So the third part, well, the second part was if you could single out, the one or maybe top three sort of killer apps. I think you mentioned, techniques used in Go and so on. And then the final part is for the future, for predictions. And no, predictions are hard, especially about the future, as they say, but they're also cheap. So, you might as well take a shot at it.
Right. So I think like immediate applications will be everywhere. So I think that small machine learning and small AI will be applied in many fields where you have a very, very well-defined prediction task that can help you. To get, to get to futuristic scenarios where AI is, very much embedded in our lives, I think we need to make a lot of progress on the scientific front. So I think the current paradigms are not sufficient to have, higher level artificial intelligence among us. But I think small applications will continue to grow. It's a growing market. Yeah.
Fair enough. Yeah. So as I want to mention that, in terms of applying lessons that were learned by games like Go and so on to kind of real life, deep reinforcement learning techniques that were used in Go are actually making a pretty big impact in things like drone navigation, for instance. And there's a number of other areas, I think, where these techniques are actually really starting to have, practical applications. But thanks, Konstantin. Let's go to Serafin.
Yeah, I agree with Kostis on everything he said. I think when it comes to what it does best, I think being able to analyze vast amounts of data and then find patterns is what has really made it advance over the past 10 years through the convergence of computation, GPUs, and the availability of data on the internet. So that's how, and we can get to that. Now, in terms of applications, basically killer apps or impressive achievements, I think, yeah, me too, was very impressed with AlphaGo beating humans in Go. Protein folding from the same team, DeepMind, has been an amazing advance over the past year, which we didn't expect protein structure prediction to become so accurate as it has already. It does a lot of things well where there is money in the economy, such as selling things. So that's why basically a lot of deep learning has been funded by, advertisement related or, social media related things of how to keep people watching ads and selling things to people. But it does some other things extremely well, such as voice recognition finally works, fraud detection in trading, machine translation finally works, search engines are very, very impressive. And in terms of the future, I think there is many, it's really difficult to predict the future, but if I wanna mention a few areas, healthcare, if it gets access to large amounts of data, to health network data, that is the main impediment. I think we can get much better healthcare to people and much cheaper as long as health networks open their data, meaning all the, like somehow patients volunteer and get their patient records, including imaging, as well as their lab results and all the drug treatments. Once we do that on a sufficient scale, what is sufficient scale? Well, a few million people. I think we're gonna get much more improved healthcare. A second area I would put is, the military. So going to drones, what you said, Kostis, I think over the next 10 years, we're gonna see the first war that is won primarily by AI, basically. So whether we like it or not, I think that's gonna be a so-called killer app for AI. And the third one, going to again predict autonomous driving over the next 10 years. I know we've been keeping predicting it. My colleague Sebastian Thrun at Stanford, when I was there, kept predicting it for 2010 and now then 2020. I think 2030 will definitely happen. And largely it's driven by, I think Tesla has had the best model in basically getting its customers to generate the data that will actually be used. So yeah.
All right, excellent. Thank you, Serafim. Mario?
Yes, hello everyone. I definitely agree with both Serafim and Konstantinos in terms of, the major part where deep learning excels is pattern recognition, and there's plenty of applications around us that have to do with pattern recognition one way or another. Now, when it comes to killer application, that the definition of a killer application is an application that actually drives the adoption of a certain technology. So, for example, email and World Wide Web were the killer applications for the internet. In that sense, we've seen machine learning being applied quite widely in computer vision. We do have image recognition and face recognition, which is quite important. It has many implications, both in the economy and the society. Speech recognition, as Serafim mentioned earlier, and I mean, it comes down to pattern matching, to pattern recognition. Then again, because as we all know, it's money makes the world go round, whether we like it or not. It's yes, it's recommendation systems. As Konstantinos said, it's about persuading and convincing people buying more stuff, which may not be the most interesting application scientifically wise, but we see it everywhere. Now, for the future, I would say that, in my opinion, AI and machine learning and deep learning will be just diffused everywhere, because more or less pattern matching is something that can be applied in a wide range of domains. It's not, it will not be just a few verticals that where we'll see this technology applied, but I mean, in every single little device or application that's around us will have one way or another some kind of artificial intelligence, most probably through machine learning.
That makes sense, yes. And particularly in connection, I guess, with the Internet of Things and everything being connected and kind of, learning from one another. So let's move on to another question, which is that machine learning has been, as a technology, it's been around for a very long time, and even neural networks have been around for many decades. What sets deep learning apart from previous machine learning technologies? What makes it so powerful? And maybe Konstantin, we can start with you again.
Right. So yeah, so deep learning has been a technology that has driven a lot of the recent successes in machine learning and AI more broadly. Deep learning is, as you said, has been, I mean, neural networks have been around for many decades. In fact, since the beginning of the field of AI. What happened in the last couple decades is first, we got access to a lot of data thanks to the internet and cheaper storage technology and so on and so forth, more sensors and this and that. The other thing that happened is maybe serendipitously, graphical processing units became very powerful, and they allowed computers to do very fast linear algebra operations, which lie in the heart of what you need to train these neural networks on a lot of data. So neural networks are basically very simple in terms of the units that that compose them. So They are, think of them as big networks of very simple computational units that you can fine tune in such a way that you recognize good patterns in data. And typically they're arranged in layers, sort of like layers that are closer to the data, are supposed to identify more fine patterns. And as you move deeper, so that's why they're called deep neural networks, and the field is called deep learning. As you go deeper inside that network of simple units, you recognize more interesting patterns in the data that is fed to the neural network. Now, these networks have very simple units that are arranged in layers, but they have a lot of them. So like not as many as the human brain, but a lot of them. And to train them, you need very powerful hardware, and also you need a lot of data. And as I was saying earlier, what we saw in the past couple of decades, we got a lot of data, and we got, as I was saying, serendipitously through graphical hardware for graphics, we got very powerful hardware, and then we took that to the natural conclusion. So we developed even better graphical units. We collected even more data. We increased the sizes of these neural networks. We connected many GPUs together in data centers with many of them, and we pushed it to the natural conclusion, right? So we pushed it so much so that now we have monster neural networks like the one behind what I'm sure we're going to talk about soon, GPT-3, that have billions of little units that all help perform some computation. So this is what neural nets are. Again, it's an old idea, but it has benefited from the hardware and the data, and a lot of innovation around how to arrange those units and how to train the neural network. Now, so I want to take all the time from the other speakers. Like the last thing I want to say is neural networks are behind a lot of the successes in the field. At the same time, science has not decided exactly whether or not deep neural networks are better than older technologies like kernel methods or other technologies that were out there. We are still trying to think why empirically they're good at pattern recognition, and hopefully we will figure it out soon. The other comment I want to make before passing the baton is to say that they also have made the world a little bit more dangerous, because the use of these deep neural networks that nobody really understands well from a scientific point of view, the moment you start embedding them everywhere, they're a little bit black boxes. You don't know what they're doing. You don't know what they will do in a new scenario. So yeah, having them in your self-driving car, good luck with that. Okay, so
absolutely, and we're going to touch on that going forward. Thanks, Konstantina. So, Serafim, do you have anything to add to that?
Yeah, I agree with all of that. It's been basically the convergence of data, GPUs, computing power, and certain technical advances that allowed us to be able to train those multi-layer networks. You can think of each layer as compressing the input of the previous layer in a given way. So to give an example, right? Let's take, not to pick on you, Konstantinos, but let's take Konstantinos' hair, right? If you look at a little patch of it and the general shape, you can probably fill it up, the whole thing, to some extent, approximately. So that is a low layer of input that the neural network will pick. Now, if we go a layer or two up, you can, if you know where a nose is or where the eyes are, you can recreate them to some extent. So that's a compression as well. So those are the types of things that neural networks perceive well now. It's basically things that can be compressed in multiple layers, which is kind of funny because a couple of decades ago, computers were really good in logical operations compared to humans, and they were very bad in perception. And now the whole thing has reversed. For a good example of what neural networks cannot do well is basically computing the parity of a set of bits or numbers, because those cannot be compressed. So I'll stop here.
Thank you, Serafin. Mario?
Yeah, there's not much to be added. It's essentially these two factors, as Konstantin and Serafin mentioned. It's the abundance of data that we have today and the processing power that we have available. And this is a typical example where, quantity matters. Because having, although the theory is the same, essentially, in a neural network, you have very many very low with low capabilities processing units, and the more you have, the better. And it's a funny coincidence, as it's been mentioned already, that companies producing CPUs were mainly focused on building CPUs that are as powerful as possible. Now, in the graphic space, because you are building an image, you have the capability of building just a small part of the image and building many small parts at the same time, and then constructing an image by putting all these pieces together. So the dominant architecture was not building one powerful processor, but building many processors that were doing the same at the same time the same thing, which were less powerful. And it was only by coincidence that this model lended well to the neural network, to a neural network application. And so now we see companies such as NVIDIA doing most of their business in the machine learning space, while they were traditionally companies that were doing hardware for graphics. It was happy coincidence, and this helped a lot fueling the progress in this space.
Got it. Thank you, Mario. So more and more people are identifying AI with machine learning and machine learning with deep learning. And some people, both in academia and in industry, find that questionable because they see machine learning as just one of many fields within AI, and deep learning as just one subfield within machine learning. What is your position on that? Do you feel that at this point, machine learning and deep learning in particular have been dominating AI so much that it might make sense, after all, to identify the two? And to elaborate a little bit on the question, basically some people think that there's a bit of deep learning chauvinism in the field, so to speak. AI is a large tent. It includes, knowledge, representation, planning, decision making, robotics, reasoning, all kinds of reasoning, constraint solving. All of these are AI areas that have been making progress, but deep learning gets all of the press and all of the attention and most of the funding. So is that a healthy trend for the community at large in your view, or not? And Konstantin, we can switch back to you.
I think the conflation is not healthy, and it's very inaccurate. So yeah, so deep learning is part of machine learning, which is part of AI. And yeah, deep learning is good at some things, like recognizing patterns in visual and speech and other data that sort of like combine local, let's say, texture with like global meaning or something like that. But they're very constrained, and they are a piece of the puzzle. But like even the important successes of Go and protein folding and poker. First of all, like beating humans in poker, I don't think it uses any deep learning. But AlphaGo uses a lot of game theory in the guts of the algorithm that beats humans. So it's not when you cannot attribute even those successes to purely deep learning. Deep learning is a component in there, but it's just one component. And I think that is bad for the field to focus your attention there, because you're missing all the mathematical grounding, you're missing all the connection with other domains that are important to, you know, to reach the ultimate goal, which is to develop truly intelligent algorithms. And you know, I said it earlier, but I'll say it again. Pattern recognition is not intelligence.
We're definitely going to come back to that. It's
Yes.
a very, very important point.
Right. Yeah.
Thank you, Konstantina. How about you, Serafin? How do you feel about that conflation?
Yeah, I don't have much to add. Deep learning is a subfield of machine learning, which is how to model data, basically, and how to classify, you know, cluster data. And machine learning is a part of AI. And I think that pattern recognition at the level that deep learning is really good at doing was an exceptionally hard task. It turned out that lots of data and computing power solves it. So we saw a huge advance in a short period of time. That's why we put so much attention to it. Otherwise, I think all the rest of the components will integrate over the next 10 years.
Mario, anything to add there?
No, exactly. It's not surprising what's happening, especially when it comes to the wide audience. It's who makes the news. And deep learning, admittedly, as technology, has provided us with solutions that seemed impossible to be solved something like 10 years ago. So yes, this confusion is expected, and it's normal. I wouldn't worry much about it, because, you know, for people who are into this field, they very well know the distinction and the capabilities of its technology. But then again, the fact alone that AI, be it through deep learning, doesn't matter, is getting so much attention from the people. I think it's an important thing in igniting discussions that need to start early on for what's about to happen in the next years.
That's a good point. Thank you. So let's move on to the next question. Some people have been warning of what they call AI solutionism, the belief that machine learning is a silver bullet that can solve any problem, and a general eagerness to use machine learning to solve the problem, even if machine learning might not necessarily be the most appropriate technique, simply because machine learning is fashionable. In engineering, that can lead to suboptimal and expensive solutions, and in science, it can lead to reproducibility problems, results that don't hold up on different subsequent data sets, because the machine learning algorithm latched on to superficial patterns in the particular data set that it was trained on. Do you have any words of advice here, either for practitioners or potentially even for people in business who are looking to use machine learning to gain a competitive edge? We already talked about what machine learning can do well, but what are the main pitfalls to be navigated in the decision of whether or not to use machine learning in the first place? And Konstantin, again, let's start with you.
In general, I'm a proponent of using the simplest solution for the problem you have, without being, you know, blinded, of course, about the possibilities that there are out there. We were talking about deep learning earlier. Like, deep learning shouldn't be the first algorithm you try. I see a lot of undergrad know nothing about statistics, anything else, and data. Let's, you know, like, write, you know, a neural net. Let's train a neural network to make some predictions. Like, this is not how you should start. You should start by understanding the domain that you're operating in, understand what has been done before, what are the baseline techniques, understand what the, you know, easy, like, trivial algorithms, linear regression, logistic regression, like all the kernel methods, like, understand the basic thing, like what the baselines can do before you start thinking about how to improve. Okay, so that's one important component. The other component is, again, prediction is not understanding. And oftentimes, when we have data, we're not really interested in making predictions within the same environment in which the data was acquired, but we want to make counterfactual predictions, like what if predictions, like what would happen if I were to change my prices to something else? What would happen if I took my Tesla car to the North Pole and started driving there, and so on and so forth. So models that, you have to understand, like, typically you have to be able to, you should be able to make these counterfactual predictions. So you have to think how to structure your, engineering solution so that you can make robust counterfactual predictions. Lastly, I mean, if you have data and you want to make predictions or counterfactual predictions, yes, deep machine learning is the right tool to use, okay? If you have no data, if you have very little data, it's not necessarily the case. So for example, I'm very curious.
Binomial roots, don't use machine learning. We have a formula for doing that, right?
For example, yeah. And in fact, in the health sciences, I haven't seen too much. And Seraphim, I would be very curious to hear Seraphim about that. But like, my understanding is like deep learning hasn't done much to change, making, understanding, using the genome to understand, how the genome relates to, phenotypes and so on and so forth. And, they don't have enough data. The data is too multidimensional to handle. So I would be curious to hear what Seraphim has to say about this.
Yeah, sure.
Yeah, so Seraphim, what do you think about AI solutionism, machine learning solutionism?
Well, okay, so to get to the general question really quickly, I agree with Kostis, absolutely. I want to add that for businesses, which you asked about, I think it would be important to basically, for the business leaders in the company to be familiar with machine learning, meaning that, okay, well, there is one thing, right? If you slap AI next to your company's name or goal, you typically get much bigger funding in the past few years. So that is a good approach generally to get funded well. But apart from that, hiring a machine learning expert and building a department is good, but that might also, there is also some conflict of interest there, because the machine learning expert, of course, wants to make machine learning important for the business goal. So I think it's no substitute for the leaders of the company to understand machine learning, at least one of them to be really technically savvy, to know whether it can be used and to what extent, and what is the right size of the machine learning team and effort in a given business. And it's not always the bigger the better, right? So going back to healthcare, great question. I love this question. I'll give you an idea. The biggest open data set today that could be used for machine learning is the UK Biobank. That is 500,000 individuals which have been sequenced at the exome level. The data is just now becoming publicly available. And they also have comprehensive phenotypic information as well as molecular data information. But those are primarily healthy. There is a bunch of diseases there. What you need, and again, the genome data is just being made available today, and there is no comparable data sets, even close to that, anywhere else. So really, the reason we have not seen genomic medicine and more general machine learning in healthcare is because health networks are extremely protective of their data, and individuals have some kind of fear in also publishing their data, but it's not so much on the individual level, it's more on the vested interests of health networks level, between caution, trying not to do the wrong thing, and also hiding behind patient privacy. So I've been saying that just like patients have the right to privacy, which we all agree to, right? If you don't want to publish your data online, nobody should force you to. They should have an equal right of transparency, meaning that if I want to publish my data because I'm a patient of a given disease and I want to help others and so on, I should be allowed, and I'm not today. So companies hide behind their finger of privacy of patients, but really what they actually do is protecting their intellectual property or protecting against lawsuits. So I think that this is the problem we have. Once we do get a few million people well phenotyped with their genomes open for a large fraction of the genomics community to analyze, we're going to see big leaps in medicine.
Fair enough. Thank you, Serafin. Mario, anything to add?
Coming mostly from a business background, I would say, and lighting up things a bit, that it goes without saying that if you do a startup today, it has to include a big dose of AI in it. I don't know why I haven't seen yet AI-enabled toothbrushes. Or maybe there are, and I haven't seen them. It helps with valuation, it helps with the marketing message, and again, it's no surprise that this is happening. But then again, jokes apart, it's when you are solving a problem, the secret is to start with the problem. And not with a solution. Now, we are talking about mainly the tech business, which, of course, it's dominated by technically minded people. And we all have this tendency to start with a solution or to get in love with a solution or a technology. So that's partly why it's happening. Partly it's because it helps with the messaging, it helps with the valuation, it helps with all this. Partly it's because technical people fall in love with the latest and greatest thing, and that they want to apply it whenever possible. But then again, as an advice, all I could say is that you start with the problem, and if the problem is better solved with any kind of AI, so be it, that's fine. If not, then the problem should dictate the solution and not the other way around.
Exactly, yes, thank you, Mario. Now, machine learning is increasingly being used in applications that are, let's say, socially delicate, in ways that impact society at large, and potentially in ways that might have negative repercussions on entire groups of people. It's been used, for example, to assess risk in criminal justice cases, for instance, to predict whether or not a criminal is likely to reoffend, which can determine if somebody is released on parole, or to determine whether somebody should be granted bail. Financial institutions are using machine learning to determine whether or not to extend a line of credit to someone. Companies and governments are using AI to help them make hiring decisions, whether or not to hire somebody. And in all of these cases, it has been widely recognized that if the training data reflects existing biases, that will inevitably carry over to the predictions of the machine learning systems that are trained on that data. Do you think that avoiding bias and unfairness is a problem that is itself amenable to technological solutions? Constantine.
Yeah, so this is a big problem with no easy answers. Indeed, this is so it's a multifaceted problem. But let me start with the statistical aspect of it. So the classical model under which we're operating in statistics and in machine learning, for the most part at least, or like the most standard model, is one where you assume that you have collected representative data for the phenomenon of interest, and you want to use that data, assuming that the future will look like the present. And you wanna identify in your data, you wanna identify patterns or maybe even causal relationships in your data to make predictions in the future, or like make scientific discoveries, right? Now, you correctly said, as you correctly said, we have observed that many uses of machine learning in, in the criminal justice system, in algorithmic hiring predictions, in deciding who to give loans to, and so on and so forth, incorporate biases that are seen in their data, in their predictions. And in fact, you might be afraid that they may even amplify them, right? Because the decisions of your systems might create new data that are then fed into future trained systems. And you can get into a vicious circle where the small bias maybe you started with, or like the medium-sized bias you started with, gets amplified and amplified, and takes over everything, right? So part of the issue is that the data that you consume from the world has incorporated stereotypes of the society, of the judges, of the banking system. There are biases in the data. Those biases and stereotypes have driven past decisions. And if your goal is to just replicate the previous decisions of a judge, right? So if you train your system to decide based on past decision of judges, now if your judges are biased, your future system will replicate that bias, okay? And that is part of the issue. But it's not only the only issue. There's a bigger issue, which is the paradigm that you're using to consume data and understand something about the world. Like, and one thing is what I said earlier, like predictions are not understanding. So if you don't understand causal relationships between the underlying variables of your problem, you won't understand, what are the important factors based on which you should make a decision versus coincidental patterns that relate to decisions made in the past by somebody, right? It's different to say judges, found this pattern in how judges in the past were making decisions versus here is the causal structure that affects whether a decision is good or bad. Uncover that and base your future system not on pattern matching to the past, but on an understanding of the world. So that's problem number one. Problem number two is, your data, of course, that you saw in the past are not representative necessarily of the data you will see in the future. So if you think that the future will look like the past, you will be wrong. The third thing is that sort of like oftentimes you make decisions assuming that the data you're consuming are independent from each other, but we all live in a society and we all live in a social network and this and that when we interact with each other. So the data we all produce and consume are dependent on each other, right? So like if you look at features of like somebody who grew up in a certain social environment, right, and a certain historical context, you can't just say that like you can extract that person from the social and historical context that you measured them, and try to predict what they will do in a new context, right? You cannot decide how well some worker will do in some company without thinking about the social influence from the other workers, and without thinking about where you measured that person, and in the past, and and in what context you want to make predictions for that person in the future, right? So there are dependencies in your data, social context, historical, temporal context, spatial context, that you have to take into account, and that's completely absent from the current paradigm. And the final thing I want to say is that data is reactive. So data is strategic. It has agency. Okay, so players in a system have agency. You cannot think of your predictions as not interacting with the agency of others. Like if you're using a tool to make predictions about who goes to college or who will get a job and so on and so forth, then those influenced by your decisions have agency, and they're going to change and their features in response to your system. Now you will change your system in response to their features, and so on and so forth. And you can get into a chaotic situation where the system never stabilizes. And from a mathematical perspective, you can prove that the moment deep networks are involved in this updating, then you are guaranteed yourself chaotic behavior. Okay, so these are a few comments and thoughts.
Thank you, Kostadina. Serafin.
Well, I will be much more optimistic while agreeing 100% with everything that Kostis said. So I think Kostis described very well the statistical technical issues with basically decisions in certain settings made by deep learning or by machine learning in general. And all of these are absolutely correct, like, uniform sampling of the search space and, independence assumptions that may not hold true, some kind of vicious cycles when training of the data creating more. All of these are true, but we are comparing them to what? Not the ideal Platonic truth. We are comparing them to what exists already. And these are humans or rule-based systems that have their own biases. And if you take each one of these technical issues, you will see that they are even much bigger in the case of humans. So let's say that judges and bails, it is very well known that judges give much more easy bail after lunch because they are full than before lunch where they're kind of like irritated. So admissions at universities and colleges are absolutely not without the bias of each administrator, including like reading an essay and crying and so on. So, and AI systems can be improved. They can be measured against each other. So if two companies use AI systems for giving loans, the one who gives loans that are more likely to not default is going to give better prices and is going to win in the long term. And when it comes to wrong bail decisions, I bet that while judges are not really judged on that, the moment AI system gives the wrong bail and then a murderer goes and murders some more people, we are going to get huge publicity. Oh, the Google AI system killed these people. So we're going to have huge higher degree of accountability for AI systems. So I really don't worry. I think things are much better with AI than with humans.
Okay. Mario?
Absolutely. To what Serafin said, that's right. Yes, we worry about bias in AI systems, but it's true that we are comparing it to humans. However, there are two problems with AI systems that they are not they can be found in humans. The first is the level of authority and the level of trust that people and the societies assign to a computer system. I mean, we are all raised with the notion, and we've exposed the notion that the computer is right. Just a silly example, you are doing some kind of an operation, multiplication, a division, okay, and you do it by hand. And then you do the same thing with a Hamburg calculator. You get two different results. Do you doubt for a split of a second that the calculator is wrong? No, of course, I'm wrong. I'm the human. I'm doing mistakes. The machine is always right. So a danger is that we may appoint a level of trust to machines, especially because they are machines, that we couldn't appoint to a person. We would be more inclined to doubt the result of person, because people make mistakes. And now that we are moving to this technology, that it's not about a straight way of processing data, but more of a black box, as it's been mentioned, and we don't exactly know how these results come. it's important also to understand that something that came as a result of a computer system, of an AI, it's not necessarily right. This is the first problem. The second problem is that in contrast to humans, machines and algorithms scale, which means that if we come up with an algorithm that does HR staff, that hires people, decides who will get hired, most probably the best algorithm will scale and it will be used by maybe the most companies in the world. Maybe the highest percent, the vast majority of hiring decisions will be made by a single algorithm, which would not be the case with humans. Would have different humans, each one with their own biases. So these are two factors that we need to be very concerned with. It's true that people have more biases than machines, and it's true that the accountability that the machines and the creators will be under will be enormous, but it can be more dangerous from a different aspect.
Yeah, and with respect to the black box issue, I think that's why a lot of people recently are paying a lot of attention to explanation, basically, right? So instead of just getting a simple result as an output from a black box, you actually get, or should get, and in fact, there are laws now being passed in Europe, for instance, called right to explanation, that demands some sort of accounting, some sort of explanation as part of the output. You get a credit scoring algorithm that rejects your loan application. It needs to state why it did so, the grounds for the outcome. And of course, there's a lot of technical difficulties for that, but it's one, I think, of the most important, kind of hottest areas in AI right now. But let's move on to what's probably the most interesting part of the conversation, which is the limits of machine learning. Now, all AI systems so far have been narrow, right? They can do one thing very well, whether it's play chess or Go or answer trivia questions, but they are inept when it comes to any other task. So the question here is whether machines will be able to attain general purpose intelligence. So what's your view here? And more specifically, do you think that there are key ingredients for human intelligence that are missing from machine learning? And if so, what are some people might say, symbolic knowledge, others might say language, others might say the ability to do domain-independent zero-shot learning. Do you think that connectionist networks will be able to achieve general intelligence by themselves? I guess we can start with that question, which is a separate question from whether or not we're ever going to have general intelligence, because that question isn't limited specifically to neural networks or even to machine learning. So let's start with neural networks. Constantine, what's your take here?
So I see no inherent reason why connectionists, however you want to define them, technologies cannot achieve general AI, general intelligence. I mean, we have one example, the human brain. We don't understand it super well. So that's why I want to be a little bit cautious when I say it depends on how you define connectionist. But under some definition of connectionist, I don't see any inherent technological reason why we wouldn't be able to achieve general intelligence. Now, as I have been saying many times in this discussion, I think the paradigm that we're using to train these things is problematic. And we have to change our paradigm and give this systems agency before we will be able to get general intelligence as a very high level remark. Yeah.
Thank you. Serafin?
This is a very difficult question, as we all know. So, and my views may not be shared with everyone. So I think that there are a number of components or layers missing. We know we are missing something. We don't know exactly what we are missing, and I will give you some opinions I have on what we may be missing. So the first layer is some kind of general purpose intelligence, reasoning, being able to do well on multiple tasks, learning from a few examples. Here it is not clear what are the ingredients that are missing. Today, we are in a phase of exploration of advances of deep learning. We really are hitting a plateau in the past few years in terms of fundamental advances and insights. Soon, we may add another key ingredient. It could be causal reasoning or something, which will lead to another leap in AI, an expansion of the tasks which we will be able to do. I think it is extremely naive to think that with what we do now and what we know, we will reach anything close to intelligence, and I will give you a few reasons for that. So first of all, one thing that we are clearly missing from AI today is emotions. And I don't want to be like soft and say, oh, humans and emotions. Emotions at one level are a very powerful search tool for humans on how to learn. If I ask you to think of something from a moment from your childhood, maybe when you were in a classroom, you probably are thinking right now of an emotional moment because they are a powerful heuristic. And the limbic system is extremely complicated, involving lots of hormones as well as very, very complex neural mechanisms that are much more complex in their wiring than the neocortex. So the neocortex of perception, we are able to do some of it with deep learning, but the limbic system really is giving us powerful heuristics in humans of how to learn. So we haven't, so that I think is one thing that we are missing completely, and it's too difficult to model so far, so we are not really paying attention to it. Going further up, another layer, there is, I think, a question of a deeper nature as to whether we will reach AI with connection in systems. And the problem with that is that we don't know what intelligence is in the human. We know certain things that intelligence does, but let's go to the question of consciousness. We know that we are conscious, right? That's a basic reality that we have. And we also know that our brain uses a lot of machinery that is neurally correlated with consciousness. And because our brain is expensive, in terms of food, it consumes about 25% of our calories. Clearly, in evolution, consciousness is important. Otherwise, evolution wouldn't pay for all this neural machinery. So now we have a number of case scenarios. We know that the AI we do today is not conscious. It's not getting any closer to being conscious. So the question will be, we have a few cases. Number one, AI reaches at some point superhuman level ability and is also conscious. I think we're very far from predicting how this could ever happen. Two, AI reaches human and superhuman level ability, but it is not conscious. It is imitator, such as like the Searle paradox of the Chinese room, right? And the third possibility is that unless we figure out the consciousness problem, AI doesn't reach human and superhuman level ability. So the question is in which of these three categories we are. It's possible that we will be in category 2 to some extent, but not under great scrutiny. So we will get AI programs that claim they are conscious. They start crying, oh, please don't shut me off and so on. We will be able to tell that actually they are missing something from humans, but they will do create some interesting legal and perception issues. I'll stop here.
Thank you, Serafim. Mario.
Right.
And I'm going to have to ask you all to be a little more aware of time because I think we're past the hour at this point, and we still have a couple of questions to go through. So, let's soldier on, move along.
Sure, I'll be quick. Actually, this is the kind of question that only by chance you can get the right answer. And we need to admit that nobody knows how this will play out, and whether the current technology will lead us to what is to what's known as general AI. Then again, consciousness, as Seraphim mentioned, it's a big issue with self-awareness, with theory of mind. Is something that's also lacking. We don't exactly know what consciousness is. I mean, we can only recognize that someone's conscious just by asking the other person. So there's no other way to measure consciousness, and there are also big debates on how this actually develops. I'm not sure that we need consciousness to achieve general intelligence. So I think that intelligence is a way of processing information. We can reach even more competent intelligence than what we have by just surpassing self-awareness and consciousness. I'm not sure that we know it. But then again, this is the kind of questions that only by chance we can get them right.
Fair enough. Thank you. And let's get to the to the last question here, and then maybe we can open up the room to questions. So clearly, whether or not we're ever going to be able to build superhuman AI is an open and controversial question. But hypothetically, just as a thought experiment, let's grant the assumption that we'll be able to do that. So we'll be able to build superhuman AI. In that case, do you think that some of the dystopian, scenarios that have been circulated could ever come to pass? So people have suggested that we might give an AI a goal to achieve, and in the process of achieving that goal, the AI might end up, wiping out the human species. I think it's fair to say that most experts regard such fears as overblown. But what's your take on this? Do you think that a superhuman AI, if we ever realize it, could actually present an existential threat to humanity? Or, do you think it's all science fiction? And Konstantin, again, let's start with you.
Right. So, I mean, I agree with Marius that this type of questions, only by chance you get right. So what I'm going to say is that I see, yeah, so first of all, the answer is yes, it is possible. If you have a more intelligent, like more able, because, again, the intelligence and consciousness and this and that are hard to define, but if you have a more able, more robust type of being, it may pose threat in competition with some other being, right? Like humans have been destroying the planet, for centuries. So now, that being said, my view on the human versus AI question is that AI is a technology that humans develop, and I see no reason why it cannot be combined with humans to give better humans. So humans that are both better than humans, and superhumans that are better than technology alone. So, and we know we have a few examples of that. We know that computers can beat humans in difficult games, but humans having the advice of these algorithms can beat the algorithms. So there is a possibility of cooperation and integration between the human species and the technology that it develops. So yeah, so the fear is a possible fear, of course, but the future that I see as more likely is a sort of like a future where humans and their algorithms and their technology are put together.
Lovely. Great. Thank you. Seraphim.
I don't see this a problem in the near or medium term future, although the theoretical possibility of an AI system surpassing humans and kind of super intelligent system, producing paper clips and making the whole Earth a paperclip, like factory. This is a theoretical possibility that we should not be dismissing that control problem. I think that for all we know and for the foreseeable future, meaning a few decades, we will know whether we are in a possible scenario like that. So I don't see this problem. But again, the theoretical possibility for the future is something that you cannot address so easily.
Mario, anything to add?
Yes. Well, we should worry about AI and about superintelligence. That's my opinion. Not for the reason that comes to mind of most people. I don't believe in the doomsday scenarios where machines take the weapons and start killing humans just because they don't like humans. The Terminator kind of science fiction that we all know. But there are many consequences to having an artificial intelligence that is so capable, more than a human, a bit less than a human, doesn't matter. The first problem is, and has already been mentioned, that this technology could be applied to weapons and to military purposes, and this will change the balance of power globally with consequences that we cannot imagine. The second is, which is also related, but not in the military space, who will own this technology, and what will be the concentration of power in this technology. This is also something very important, and I hear sometimes people say that, well, at the end of the day, we can unplug it if it becomes dangerous. No, that's not the case, because there will be so many dependencies on these systems that at some point we will rely on these systems as countries, as societies, in order to get guidance, to know what to do next, that we couldn't live without it. It's like someone, saying that we can unplug the internet. It couldn't be done. So there are many things that we need to worry about, and it's something that I think it's useful to have the conversation start early on instead of waiting the problems to emerge.
No, thank you, Mario. I think that concludes the list of questions. We can open up the floor to questions from the audience. And at this point, very briefly, since we're opening now the more general discussion, I just want to make a point about the human brain being an instance of the connectionist system, not unlike neural networks. I just want to say that neural networks are supposed to be inspired by the human brain, but at least so far, the way in which they operate, and I think that's been considered by the analysts, and particularly the way in which they learn, is completely implausible from a cognitive perspective. An object recognition program requires millions and millions of training examples to recognize a relatively small number of concepts, whereas even a child can learn to recognize a new animal with just a handful of examples. Also, most deep networks are easily fooled by so-called adversarial examples, where someone makes a tiny imperceptible change in the input to the model, but that change has a huge effect on the model's prediction. So if you take a picture of an elephant, right, and you change a few pixels, the result, of course, still looks like an elephant to a human, but you give that to the network, and now it tells you that it's an airplane or a skyscraper or something outrageous. So there's definitely some crucial elements in our brains that are missing from our current architectures. It could be, backward feedback connections. It could be access to symbolic knowledge and reasoning. It's not clear yet, but certainly the analogy between the brain and neural networks, as we know them now, is a very loose metaphor rather than serious and precise scientific claim. All right. Questions? Do we have any?
Yeah, I think there are some in the Q&A section. Can you see them?
I see a few. I see one about reinforcement learning and whether it's a promising area of machine learning. And yes, personally, I think it's a very promising area of machine learning. It tries to tackle one of the key present limitations of machine learning, which is the supervised paradigm, whereby you need a lot of training data to train your system. Whereas with reinforcement learning, you can set an agent loose in an environment and they just try different things and they get rewarded or penalized, and then hopefully learn a policy that can actually help them achieve their objectives. And I think particularly the marriage of reinforcement learning, which has been around also as a technique for a very long time, with deep learning is particularly promising. But that's my own take. Constantine, Seraphine, feel free to jump in here.
Yeah, absolutely. In robotics, we've seen some very impressive applications of reinforcement learning. So robots are starting to be able to walk around and do interesting things, still not human level, but definitely getting there. Of course, AlphaGo is a good example of reinforcement learning, learning to play on its own. Yep, very impressive area of advance.
Yeah, so reinforcement learning brings a piece of the puzzle in the picture, and that is state, and also understanding the impact to state of your actions, the impact to the state and your reward in the picture. It's still missing a lot of other components, but yeah, it's certainly an important step in the right direction.
Mario, I take it that you agree with that.
Not much to add. It's definitely one of the weapons that we have available, but then again, that there are so many open problems, especially when we are talking about general intelligence, that it's just one of the many methods.
Right. I see another interesting question here. That basically says that machine learning, deep learning so far is very specialized, performs one thing very well, not so good at transferring knowledge from one operation to another. Generally speaking, we live in an era of specialized AI, and the question is, in your opinion, what's the most important thing that will take us from special AI to AI? Whether it's the reliability of the training data or the expertise of software engineers and data scientists and a few other alternatives. And maybe now that I can join the panelists expressing opinions, maybe I'll venture one of my own here. I completely agree. I think it was Jeff Dean from Google who said that the way machine learning systems are built today, people like a human who wants to learn something new. And to do that, you have to forget everything you know. You forget all of your education, and you go back to being an infant. And now you try to learn everything about this task from scratch. That's the paradigm right now for building machine learning systems, and it's really both psychologically implausible and really inefficient from an engineering viewpoint. And we've made a little bit of progress here with transfer learning, which I think the person posing the question alluded to. Where in vision, for instance, if you train a deep network to recognize animals, and then you want to build another network to recognize humans, you don't start from scratch. You take some of the lower layers of the existing network that compute, fairly low-level features like edges and so on, and then you use them in your new network or in, language models. You take a huge, let's say, transformer-based language model that's been pre-trained on something like MLM, massive language modeling, and then you just fine-tune that on a very different downstream task. So you get a fair deal of reusability, but really we're just beginning to scratch the surface here. We have a very, very long way to go. In my view, it's really not just a matter of training data. It's not just a matter of good engineering and scientists kind of pushing the envelope forward. I think there's fundamental ingredients that are missing. And the most important one, to summarize it in a simple phrase, is common sense. A human knows that if something gets pushed, then it's going to move. And it's going to move not just by coincidence, right? It's going to move because it was pushed. So we have an innate conception of causality, that something cannot be in two places at the same time. That if you're looking at a box on a table and then you look away for a second, the box is still going to be there unless somebody moves it during that time. We know that people have beliefs and they have goals and they want to achieve their goals, and they use their beliefs in order to achieve their goals. And if they don't meet their goals, they tend to be unhappy and so on. So we have this tremendous wealth of common sense knowledge about physics, about biology, about other people, and so on. And that knowledge is just absolutely essential for problem solving, for navigating the world successfully. And we haven't found a way to impart all of that folk knowledge, as they call it, to machines yet. We couldn't do it with rules, with expert systems, and we haven't been able to do it with machine learning either so far. It's clearly, in my view, the secret sauce of evolution. For now, anyway, it's secret, right? But unless we find some way to give machines that kind of common sense, which underlies the ability for abstraction and analogy and metaphor and so on, we're not going to get to general intelligence, in my view.
So if I may add to that, just a thought. So you mentioned earlier adversarial examples, which are adding small perturbations to images that are imperceptible to the human eye, which nevertheless completely throw off image recognition software to call a car a cat, okay, or whatever. So to this question, so an easy way to make a neural network believe that everything is a cat is to take a little bit imperceptible amount of fair and sprinkle it on your image in an imperceptible way. Take any image, sprinkle a little bit of fair, like cat fair, imperceptible amount of fair. The neural network will think it's a cat. Why? Because the neural network has never played with a cat. The neural network is not embodied intelligence. The neural network was given a bunch of examples of cats and a bunch of examples of dogs and this and that, and is asked to solve a very specific problem, to look at the pixels, predict the content, right? And somebody curated that data set. Maybe the curation is not complete and so on and so forth. So I think that the way humans learn about, like cats, and the way humans learn about, gravity and, the persistence of objects when they move behind, the sofa or whatever, is because they have embodied they're not hardwired that information, or at least certainly not all of that information. As the baby grows, they actually figure out these rules of thumb, even though they have some intuitive understanding of physics and intuitive understanding of causality and presence of objects when they hide behind things. So a big paradigm shift is to get real intelligence is to have embodied intelligence. So we can still use machine learning and deep learning and this and that for very specific tasks, as long as it's a very well-defined problem. But you can't hope to have intelligence if you don't have an entity that has agency and a body and can grab things out of their own intent and collect their own data and define their own challenges.
Yeah, embodiment is a very good point, and situated intelligence in general, as they call it, is just a crucial element of intelligence. I think that realization has really started to take hold in the community over the last couple of decades. But in terms of the how brittle neural networks are, it's the same thing. I mean, we've been talking about visual understanding and image recognition, but it's more or less the same thing with language. So even something like very sophisticated language models or neural networks that can answer questions, right, on the basis of passage of text. You give it a paragraph or a couple of paragraphs to read, and then you ask it a question about the paragraphs. And they perform okay, trained on millions and millions of examples. But if you add, at the end of the passage, just a slightly different, sentence that really has zero impact on the meaning of the entire passage, and a human would just clearly, filter it out as irrelevant, the answer of the deep learning system becomes just completely completely irrelevant. It's just outrageous. So there's actually a fair amount of research going on right now. The term that's been going around, the phrase is clever hunts. I don't know if anybody has heard the term, but it was a course in early 20th century, clever hunts, that supposedly understood German and could do arithmetic. And people would gather around the horse and his owner, and they would ask it questions like, what is 12 divided by 4? And the horse would answer by tapping his hoof 3 times. And of course, everybody was amazed, right? And they finally figured out that the horse had learned to start tapping when people turned their attention to his hoof, when they started looking at his foot. And once the correct number of taps was made, people would exclaim and they would look away. And then Hans would take that as a signal to stop tapping. And some research scientists are, claiming that deep learning networks are basically like clever hunts in that they latch on to kind of meaningless statistical patterns that just happen to be robustly correlated with the right answers when the questions are posed in the right sort of environment, but without really having, the faintest understanding of what's going on. So there's a number of papers now examining the question of whether deep learning models in natural language is just clever answers. And frankly, the jury is still out on that.
I mean, this can be enough in some applications, but you have to be sure that your application is one where pattern recognition is enough. Don't use it when it's not enough. That's the point.
So we have another interesting question here. What do you think will be the impact of AI in the general workforce? Is it going to result in job losses? Do you believe that AI knowledge will or should be the core skill for future workers? Any takers here, Mario?
Well, yeah, definitely. I'm not very optimistic in this aspect. Yes, we will face a lot of disruption in the job market, just because stuff that couldn't be automated until now, it will be automated. And I mean, I tend to agree, although I don't like it, with what Yuval Harari mentions as the emergence of a useless class, meaning a percentage of people that may not be needed in the production system. The goods can be produced without so many people included in the production process. And this is something that can be solved only through politics. But it will bring in the near future, and by the near future, in the next decades, it will bring a lot of changes and a lot of disruption in the job market.
Yeah, I agree with that for sure. I think a lot of jobs that involve human contact will actually be saved because we like human contact. But a number of jobs that are either very, like in industry, like can be roboticized, or even require human expertise, such as legal and paralegal and finance sector and so on. Some of the doctors or medical assistants, a lot of these positions will become redundant from AI. Self-driving, of course, I think that is also an area where we will see massive displacement of workforce. So I still think that even low-level jobs that require a human contact, and maybe that will be a partly a replacement of job force. So basically being able to have a lot of services type work that requires human contact, such as taking care of babies and elderly and so on.
I'm a little more optimistic, and maybe we can take the example of self-driving cars here. Even going back 5-10 years, people were predicting that by 2020, truck drivers are going to be out of the job. As the saying goes, 90% of a project takes 10% of the time, and the last 10% takes 90% of the time, or sometimes it never gets done. Right, so it's usually fairly easy to get to 85 or even 90% accuracy, but getting to 100% is very, very difficult. And I think that's what we're seeing now with self-driving cars, or even with top object recognition and situation understanding, text comprehension, which you absolutely need if you're going to be replacing a paralegal. We're seeing how difficult it is to deal with a long tail because there are essentially infinitely many scenarios that might come up during driving or in a completely arbitrary picture or in a completely arbitrary text. And no matter how much data your system was trained on, it's not infinite. The tail will always get you with situations that might come up, that just you never trained on. And that's what's happening now with self-driving cars. So a Tesla, fails when the snow is covering the lane lines. So the engineers go back and make up some new training examples with snow to pass things up. Then the car fails when the stop sign has some graffiti on it. So the engineers go back to train new examples to cover those cases, and so on and so forth. And in some sense, the situation with me is reminiscent of what happened with expert systems back in the 80s and 90s, or even with Psych. The huge knowledge base that they've been building forever. So expert systems worked amazingly well in typical narrow circumstances, and by the way, they were explainable, right? You would actually get beautiful explanations of their reasoning along with the outputs. But reality would always intervene and throw up a long tail input that was not anticipated. And then the engineers would go back and add a new rule or some new facts, and so on and so forth. And of course, people realized eventually that this, could never scale in practice. And I think the same thing is happening now, at least with some, machine learning systems, except that now we go back and we add more training data rather than more rules or facts. Because in some sense, by moving from rule-based systems to machine learning systems, really, we've only pushed the bugs under the carpet in some sense. We basically moved the knowledge bottleneck from rules to training data. But it's really the same underlying issue in both cases, the fact that neither type of system has any common sense, and they're both very brittle as a result. So for the near and medium term future anyway, yes, we will have some job losses, but I think they're not going to be anywhere near as extensive as a lot of people fear. Constantina?
I agree with what has been said. I think there will be big. Think of the internet economy in the past 20 years. That was a huge impact on the labor force. We cannot deny that. So every new technology is going to bring a huge shifting of in the labor force. But humans adapt, and I think the biggest lesson is that you have to be you have to be able to adapt to perturbations of your job environment, And at the same time, policy has to adapt and make sure that, first of all, workers are, have the skill to adapt. That's an important maybe piece that, was missing from the education system. Hopefully, it's being improved. And also, in the case people are massively displaced from the jobs, step in and give them the time to adapt to a new position, a new job. So I think there will be massive changes, but it's gonna happen relatively smoothly, and policy should though step in when there are big changes.
Another interesting question is, do you think that we're going to face an AI winter too in the near future? And the term, I think, refers to the AI winter that happened back in the 70s and large chunk of the 80s, where the funding basically dried up for connectionist research due to largely, a book by Minsky and Poppert that basically expose some limitations of certain types of neural networks, basically linear models. But do you think that an AI winter, I guess, in the second incarnation might emerge in the near future?
Well,
yeah, go for it.
I don't think so. I don't think so. We are done with AI winters, and there is a simple reason for that, in that there is enough AI deployed today with massive economic footprint that if those entities, and many more that will be developed, but even the ones we have now, if they stop funding AI, a competitor will take their business. That goes from Google and ads and everything else that AI. So we're done with AI winters. We are going to keep investing hundreds of billions of dollars a year in AI in perpetuity.
Right. Well, the other fundamental difference, I think, between the 70s and the 80s and now is that back then the funding that dried up was almost exclusively coming from the government. Whereas now, as I think you just suggested, there's this tremendous amount of private investment from big tech companies in the field, and that's definitely not going to dry up anytime soon. Anything to add, Mario Constantino?
Oh, I mean, definitely it has become such a central part of the current technology and economy. So much money deployed, so many people involved in this that it's nothing close to what happened in the 70s and the 80s. We are in a totally different situation. No, I wouldn't bet that there will be a winter.
Yeah, so just to add, I don't think there will be, at least not anytime soon. I don't think there will be. The reason is that we discussed a bunch of limitations of the technology. Nevertheless, there is a value proposition here. So the tools are very good at what they, some tools are very good at what they promise to do. Some tools are trying to at least cover 85% of the way. But even if you have 85% of the way, that is a value proposition, right? It is a value proposition because you only need 15% extra to get to completion, and that 15% extra could come from a human. So that is a value. That's a value proposition, and we have plenty of fuel to go with, even with the current limitations of the technology. This is being massively deployed. We have a lot of data. We have the hardware. There is progress being made on the scientific front. I think we're not in a similar scenario like the 60s, like the 70s or the 90s, where the technology wasn't quite there, the data wasn't quite there, the hardware wasn't quite there, the science wasn't quite there. So I think it's a very different scenario.
Thank you. Yeah, well, we're 10 minutes over time. I think by now we've discussed pretty much all of the questions that were posed. I want to thank the panelists and our gracious hosts. And I think we can pretty much conclude the proceedings. I don't know if Panagiotis or Ioana will step in and say some final words here.
Yeah, first of all, thank you all for your time today. I hope we had a little bit more because I know that it's been really interesting for everyone. So I would like to thank you all for you because it was one of our biggest and most insightful webinars. And of course, for all of you that you joined, I hope that you find it really insightful. And please stay connected to Endeavor's newsletter to receive a full transcript. I think that's it. Panagiotis, do you want to say something?
Thank you everyone for the very interesting conversation.
Yeah, and looking forward to seeing you in our next Rethink webinar. Thank you.
Have a great day.
Absolutely. Thanks, everybody. Bye.
Bye-bye.
Bye, everybody.
Bye, everyone.